IB maths is easy.
Number 5. Given that the tangent S1 parallel to this line, so this means they have the same slope. First, we need to find the slope of the tangent S1. So we need to find the first derivative. So fx is 2x minus 1 times with e power kx. So we need to use product rules. So a equal with 2x minus 1. So the derivative of a will be 2. B is e power kx. So the derivative of b will be k times with e power kx. So the slope of tangent at 1 will be, so this is the formula. And then we sub x equal with 1. We will have 2 e power k plus k times with e power k. And this is equal to the slope of this line, which is 5e power k. Divide every term by e power k. We will have 2 plus k equal 5. So k equal to 3. We can divide this one with e power k because e power k will never be 0. Okay, 6. I describe two transformations. Okay, it's easy that we can see that if f of x minus 3 pi over 2 plus q will equal with gx. It will look like exactly like this one. So we have transformation here. This is the first one and this is the second one. This will be move or translate to the right, 3 pi over 2. And the plus q will be move or translate up, q. Okay, B. Find the y-intercept of g. Identify the value of r. Given that g is bigger or equal to 7. So the mean of gx is 7. And the mean of gx will be negative 4 plus 2.5 plus q equal with 7. So we know that q is 8.5. So now we have the g will be 4 sine of x minus 3 pi over 2 plus 11. Okay, so to find the y-intercept, we sub x equals 0 in. So it will be sine of 4 times sine of negative 3 pi over 2 plus 11. Sine of negative 3 pi over 2 is 1. So 4 plus 11 equals 15. And that will be the value of r. Okay, number 7. This is the graph of first derivative of f. And with this equation, quadratic. Okay, a set of symmetry is also the x of vertex. So the q will be negative b over 2a, which is 12 over 6, which is 2. So the value of c is 2. Okay, the vertex. Okay, the vertex is on the x-axis. That means only 1, 0. So the discriminant is 0. And we use that information to find p. Okay, so the discriminant will be b squared minus 4ac, which is negative 12 squared minus 4 times 3 times p equals 0. So we have p equal 12. Find the values of the gradient of first derivative at 0. So gradient, so we must find the derivative of the first derivative of f, which is the second derivative. So the second derivative of f will be 6x minus 12. So second derivative at 0 will be negative 12. Okay, scratch. Identify clearly x-intercept and y-intercept. Okay, so we have a linear function here with the slope of 6 and the y-intercept as negative 12. So let's draw it down. So this is negative 12 and this will be 2. So this will go like this one. This is the graph of second derivative. Okay, from the graph, write down a point of inflection, which is the second derivative, will equal with 0. So we try to find the x-intercept. So the x-intercept is 2. So a is 2. Find x, which concave down. So concave down, that means the second derivative will smaller than 0. So clearly we can see from here. So when x smaller than 2, justify the answer. Okay, look at the graph of the first derivative. When x is smaller than 0, the first derivative decrease. So that means the function will concave down.